So I'm Russell Moore, one of the founding partners at SparkRed, and I've been working on ATG/Oracle Commerce for almost 2 decades. SparkRed started out around 10 years ago with a focus on this technology. We offer deep knowledge in the Oracle Commerce product and e-commerce in general. We bridge the gap between commodity-based hosting and systems integrators to manage our clients' security, uptime, scalability, and to troubleshoot issues deep into the application stack. There are 2 primary reasons any e-commerce site should implement a content delivery network. Today I'm going to discuss both speed and security as they relate to Oracle Commerce and really e-commerce in general. And while this is not really meant to be a direct sales pitch for Cloudflare, they are our CDN partner for good reason. Many of the things I'll discuss today are features as they are implemented in Cloudflare. So we've all heard statistics for page load times and conversion rates. According to Pingdom, the average page load time in 2015 was around 5 seconds. Google Site Performance has some expectations for this, though. They state that, quote, 2 seconds is the threshold for e-commerce website acceptability. At Google, we aim for under half a second, unquote, which basically means that faster sites get preferential treatment when it comes to SEO rankings. Over the last year or so, we've seen some emerging trends in e-commerce. Definitely, we're seeing a huge shift to mobile device usage. We have one retail client that currently reports around 70% of all their traffic is on mobile now. We see a drive to use reactive design frameworks and a shift away from third-party mobile or MDOT type providers to reactive or adaptive rendering of the site. Headless commerce, which is really the separation of content rendering from transactional and data integration through your e-commerce platform. This is meant to speed up both the customer experience as well as the time to market for content changes. And finally, we are starting to see more effective usage of full page caching. There are 2 primary but not exclusive approaches to full page caching. The first uses cookies to tell the CDN to bypass cache and forward the request back to the origin, say if a user signs in or adds an item to cart. In this approach, we would inject a custom servlet near the end of the servlet pipeline to set a cookie if one of those events have been fired. The second approach is using dynamic HTML and AJAX calls to fill in sections of a page with quick calls back to the origin, while leaving the bulk of the page cached and served directly to the user from the CDN edge server. I'm going to dive into this last approach a bit and talk about how we use CDN to minimize traffic impacts on the origin and serve up pages that are apparently much faster than the traditional pull every JSP from the origin approach. When a user's browser hits a site and requests a page, these are the basic steps that it follows. First, the browser sends a GET request to the server, and the server returns this text-based HTML document. The browser parses the HTML and looks for linked resources to load and makes requests for those assets. The browser uses the CSS and images in the HTML document to start laying out the page. Then any JavaScript calls that have been coded in that page, ideally they've been written in a non-blocking asynchronous way, can manipulate the document and its layout. So if we look at the actual content of a rendered page, what's truly different between users? The logged in state, the cart contents and count, and maybe some personalized content. So what if we rendered a standard page as if the user was not logged in, then made a secondary call back to the server to see what the user's state information was? If the user's logged in, we can swap out the login/register block and then make another call to replace the personalized content blocks. The user has items in cart, we swap out 0 for the cart count. We could cache that first response HTML document at the CDN layer alongside all the images, style sheets, and JavaScript. The CDN can deliver a near immediate response, and then small AJAX calls can swap out the dynamic content before the user even realizes it, making the site appear much, much faster. So what can we cache? Obviously, we can cache static assets, images, style sheets, JavaScript. This was the beginning, of CDNs. All of them kind of did this as a core competency. But if the personalized content blocks are not really unique to the user, but to a segment, like a user segment like men or women, we can cache the individual permutations of that content block as well, right? Also, if you're implementing real headless architecture, you can also cache some REST calls, such as REST services that give catalog or store location JSON responses. In Oracle Commerce 11.3, they implemented a new and improved REST framework, wrapping many of the most common commerce services that you might need. Some of the examples I put here. So something like the product catalog actor, which serves up product catalog data, would be something that you could cache at the CDN, while the user profiling profile actor, is a handle on the user profile, you wouldn't cache, obviously. So we can cache reference data calls, but we don't cache transaction calls like add item to cart or handle login, or state calls, such as the user's logged in status or cart contents. So if we look at mobile traffic patterns, while we see a generous increase in mobile traffic recently, we also see a huge disparity on how users are using mobile and its effectiveness at checkout. 93% of users who research a product on mobile end up purchasing. But 32% of traditional desktop users who add an item to cart eventually purchase, while only about 3% of mobile users actually complete the purchase on their devices. So what's the problem? Well, people expect mobile to be as fast or faster than desktop. However, this happens over wireless networks that can be much, much slower, and on browsers that are significantly lower powered than desktop browsers. Also, the downside of responsive design is that it can be heavy. It can serve up images larger than necessary and duplicate content that gets switched out on the client side. And finally, as designers, we need to think about the mobile experience and ease of checkout. The opportunity is obviously huge, and becoming a leader can improve your site's position against competition significantly if you can change that conversion rate for mobile, right? So let's look at how we can address some of the performance issues using the CDN. CDNs with a focus on mobile commerce should have these features here. They should have direct peering with mobile network operators, which minimizes the network distance between the CDN edge servers and mobile gateways, right? They should have the ability to detect and execute different rules based on the device types making the request. They should be able to optimize image delivery, providing progressive downloads and shrinking image sizes automatically. They should do on-the-fly video transcoding and be able to provide adaptive bitrate streaming based on the connection speed of the device. So can we do full page caching on mobile as well? And why not? The idea of responsive design is that you serve up the same content, but let the browser define how it's laid out and how it looks on the fly. With responsive design, the content doesn't actually change. But optionally, we can also develop to switch page rendering based on user agent back at the origin. And then we can cache user agent specific versions up at the CDN and let the CDN device detection rules serve up appropriate versions of the cache page. Again, all this is meant to provide near immediate responses back to the user. So I thought this topic was worth mentioning, though I've only just started reading about its application in e-commerce. Accelerated Mobile Pages, AMP, is a Google project that was originally designed for distributable content like news stories or blogs. It's basically standard HTML, but you have to follow some special rules that are designed to make these pages super fast and cacheable on mobile devices. AMP pages are published and they can get cached elsewhere as well. Cloudflare has a plugin that will prefetch content from accelerated mobile links. I've included a link to an article written about using AMP for e-commerce here. Now I want to talk about some advanced CDN capabilities. The first one is HTTP 2. HTTP 2 is the first change to the HTTP protocol in over 15 years. It's based on the Speedy protocol, which again was a Google project. It basically gives us 4 new features: multiplexing, server push, stream priority, and header compression. Multiplexing is we send multiple requests and responses over the same TCP connection. In standard HTTP, this is like going to the grocery store for one item at a time. right? Browsers have worked around this over the years by upping the number of threads that they use, but each thread can only still get one asset at a time. Multiplexing is like going to the store and getting everything at once. With server push, the server can direct the browser what you will need. Say you buy taco shells and the grocer suggests that you get salsa, ground beef, seasoning, and cheese. It's kind of like that. You ask for the HTML document, it says, hey, I know you're going to need this style sheet and you're going to need these images, and then pass those forward on the same connection. Stream priority is related to multiplexing. The client can prioritize which things it gets first. Say, I need the HTML first, then the CSS, right? And then header compression reduces the amount of data that has to go over the network and be parsed by the browser. HPAC is a new compressor that comes with HTTP2 that also eliminates redundant header fields. It's improved security over Speedy's deflate compressor, which was susceptible to the crime exploit. Other optimization features include Mirage, which is an image loading optimization for mobile devices on slow networks. Puts up a low-res placeholder image while the larger ones are loading. It can combine multiple individual network requests for images into a single request, and it can also enable lazy loading. Polish automatically reduces image size by compression and removing metadata. Auto minify and compression shrink down the overall size of the assets being sent to the client. And use of geolocation and true client IP address headers, including support for IPv6, can help you determine appropriate content automatically, such as automatically sending back locale-specific pages or more meaningful store location results. Some clients have added code to grab the client IP address from the DynamoHP servlet, DynamoHP request object and store it as a custom extension to the order for later reference. You could even use this to do a simple velocity check. You could flag orders that have exceeded an order limit in a given time period from a single IP, which could indicate fraud. So it seems like every few months there have been new critical threats identified. It's a constant fight just to keep abreast of all of them, not to mention to take action to prevent them from prevent you from becoming a statistic. There were over 1,000 reported large-scale corporate data theft incidents last year, with an average consolidated total cost of data breach being around $4 million. In addition to data theft concerns, there are also those that try to overload your site with traffic to cause performance issues and in some cases downtime. The number of such attacks has increased dramatically over the last couple of years. So how do we combat this with our CDN implementation, right? If we break threats into these two generic areas, there are traffic-based attacks, commonly called Layer 4 transport layer attacks, and application-level attacks, also known as Layer 7 attacks. Right? Your CDN should have controls in place to automatically help prevent Layer 4 attacks. And then you can implement a web application firewall, either on your web servers, but ideally on your CDN should have this capability as well, which would prevent malicious traffic from ever hitting your origin. You start out by selecting a CDN with strong built-in security features and a very large network capacity. You should lock down your origin servers so they only accept traffic from known IP addresses. Those are the CDN and those of any dedicated monitoring solution you might have, such as Pingdom or New Relic. This prevents attackers from directing traffic around your CDN and getting at your origin directly. It's not much good if you implement protection at your CDN and you leave the front door open, right? You should implement the WAF on the CDN, limiting potential malicious traffic that will actually hit your site. There's a standard set of rules, which are basically actions taken against recognized attack patterns, called the OWASP rule set. Cloudflare also has additional rule sets based on your platform, such as specific known exploits for PHP or WordPress-based sites. You should enable rate limiting on high-value resources and enable browser integrity checking as well. So here's my recommendations for local commerce sites as far as effectively implementing CDN features. Move your site to an all SSL site. The HTTP2 requires this to be really effective. It also will provide SEO rewards. If you can implement this, you can implement this as a protocol switch, servlet, or even at CDN level, providing redirects from HTTP to HTTPS resources. Lock down your origin. Only allow CDN and monitors to hit it directly to protect yourself from circumvention origin attacks. Move toward rewriting your JSP pages so they deliver customer ambiguous page, which can be cached to CDN, and use AJAX calls to fill in the dynamic bits. Implement responsive design for mobile. Enable HTTP2 at the CDN. Related, you're going to want to remove old performance workarounds, such as using multiple host names for the same site to get higher parallelism from the browser. These will actually work against you if you're implementing HTTP2. Spend some time reviewing OWASP and other WAF rules, and turn off ones that don't apply or cause problems. In particular, we've seen many pages that have RQL arguments get flagged as false positives for SQL injection attacks. As long as your development team is using ATG repositories and related access methods, ATG is generically safe from SQL injection attacks. So you should be able to just turn this off, for example. Look at locking out geographies you never service. Do you ship to Russia, Nigeria, or China? These are some geographies that are high risk and may not provide any reward. Turn on rate limiting for import resources. Example of this, we had a client that made an expensive call to a back-end service to retrieve gift card balances. An attacker that knew this could target that one page with a minimal number of bots and take out the site by overwhelming the available threads. Ideally, your application should have some protection against this as well, such as using a pool of connections and failing quickly if the pool is exhausted. Finally, turn on browser integrity checking. Weed out the unsophisticated bot traffic easily that way. And with that, I'm going to turn this over to Nick, who's going to talk more extensively about how Cloudflare supports all of this.
Okay, hi everybody. My name is Nick, and I'm a solutions engineer at Cloudflare. Now, Cloudflare is one of the leading security and CDN providers out there. CDN standing for Content Distribution Network. And I'm going to spend the next few minutes just explaining a little bit more about how Cloudflare works and how you can implement the suggestions that Russell has made on optimizing your Oracle Commerce website. So first of all, just a couple of facts about how Cloudflare and Oracle Commerce work together. There are 63 major Oracle Commerce sites on Cloudflare, including American Apparel, Sur La Table, and Schumol. So it's tried and tested. There are many customers out there using those two platforms together. And Cloudflare is super easy to integrate. You can literally be running Cloudflare in a couple of minutes. It's really easy to set up, and there's no downtime. It's very, very easy to integrate. And you keep your existing hosting provider or server set up. Cloudflare just sits in front of your existing service to help protect it and optimize it. So there's no changes required on your hosting side of things. So let me explain a little bit about what Cloudflare actually is. So you can imagine here, this is before Cloudflare is implemented. You can imagine your website on a web server. Basically, your visitors can connect to the website. Crawlers and bots can connect to the website. And also attackers can connect to the website. So those are the kind of users out there that are connecting to your site. Some of them are good. Some of them are legitimate shoppers coming to buy things from your Oracle Commerce site. And some of them are attackers who might want to take the site down or maybe steal some data from the website. So if you implement Cloudflare, Cloudflare is essentially a layer that sits in front of the website between the rest of the internet and your web server. So this means that any requests to your website have to pass through Cloudflare. So legitimate visitors pass through Cloudflare. Crawlers and bots, the ones you want to let through can get through, because obviously you want things like the Google crawler to be able to crawl your site, but you might want some malicious crawlers to be blocked. But attackers, particularly those carrying out maybe a DDoS attack, a distributed denial of service attack, they will get stopped by Cloudflare. So Cloudflare is this security layer that sits in front of your website. And as well as providing that security layer, Cloudflare can also start accelerating the content. So because Cloudflare is sitting in front of your site, Cloudflare will essentially store some of the content on Cloudflare's system and serve that content from Cloudflare, which Cloudflare can do much faster than having to serve that content from your own web servers and own web infrastructure. So this is Cloudflare's global network. We have 115 data centers around the world, which is where we actually provide that security and CDN service from. So these 115 data centers around the world are basically, our aim is to get as close as possible to the internet users. So whenever a Cloudflare, a user connects to a Cloudflare-powered website, they will always connect to the nearest Cloudflare data center. So there are about 6 million websites protected by Cloudflare, small websites and large websites. And we see about 10% of all the global web requests. So that is a huge number of web requests that are passing through Cloudflare, and the statistics, speak for themselves. We see about 1.4 trillion page views per month, 1.2 million DNS requests per second served by Cloudflare, and about 5 million HTTP requests per second. So, why is it important that we have this large footprint, these 115 data centers around the world? Well, it actually helps us not only get closer to the users, as I mentioned just a moment ago, but it also allows us to have a massive footprint for dealing with distributed denial of service attacks, which I'll talk about in a bit more detail in a moment. So that's our network, and that's basically how Cloudflare works. Cloudflare servers around the world will sit in front of your website and provide that security layer and that caching and optimization layer. So, these are the three main features of Cloudflare. We provide reliability for your website through providing very solid DNS services, and optionally, if you have business in China, we can provide our services in China where the internet is notoriously unreliable, and we can help fix some of the problems that e-commerce websites face in China. We provide a security layer, which is protection against DDoS attacks. We can do things like rate limiting, which help restrict the number of web requests that might be malicious coming through to your website. And we have that performance layer. So we can help ensure that the website is speedy and has high uptime thanks to services like load balancing, which means that if your website is hosted across multiple servers, perhaps those servers are across multiple data centers, we can ensure that you have very high uptime. And the key point about Cloudflare is all these features are included for a single monthly fixed price. So it's a very predictable price for this service. So let me talk a little bit more about security. Russell has already sort of touched on this a little bit, but essentially, the trends, the DDoS attack trends are evolving. So DDoS attacks are getting larger and much more complicated. DDoS attacks are essentially, for those of you who don't know, when somebody sends so much traffic to your website, it basically takes the website down because the web server cannot handle that volume of traffic. And the trend is these attacks are getting bigger and bigger. And last year in 2016, Cloudflare saw one of the largest DDoS attacks in history of a 1 terabit per second. That's 1,000 gigabits per second. And Cloudflare's global network, which has a capacity of about 10 terabits per second, was able to handle that with ease. So that's why we have that large footprint around the world with those 115 data centers around the world, just so we have a huge amount of capacity to handle these large DDoS attacks. And the important thing to consider is, how much would it cost your business to have a few hours or maybe a few days of downtime due to a DDoS attack? we've seen some customers who have suffered days and days of downtime due to ransom attacks, for example, whereby an attacker will say, we're going to attack your website with a huge DDoS attack unless you pay us, this amount in Bitcoin. And there are malicious people out there who are trying to take down your site. So implementing a service like Cloudflare can help protect you against those kinds of threats. So as well as protecting against these kind of DDoS attacks, these large distributed denial of service attacks, Cloudflare also has another security layer. So we receive, as I mentioned earlier, 5 million requests a second that come through Cloudflare, 5 million HTTP requests per second. So we see all this traffic, and this helps us build up a picture of the good IP addresses out there and the bad IP addresses out there. We have a proprietary IP reputation database, and we can start building up a picture. This IP connecting to this website, it's a good one, let's let them through. But this IP address, we've seen that IP address make a lot of attacks on Cloudflare customers. We're going to challenge that IP address or block that IP address completely from connecting. So, Cloudflare's second layer of defense is our IP reputation database. And we also have something called a web application firewall. A WAF basically protects against things like SQL injection, cross-site scripting. Basically, it helps protect against vulnerabilities that might be on your website or on your application. So the web application firewall actually inspects every single web request coming to your site and checks that it's a legitimate request, and if it's a bad request that's trying to maybe exploit some vulnerability on the site, Cloudflare will block it immediately, and the traffic will go nowhere near your web servers. And this graph here is just showing the advantages of using a cloud-based service like Cloudflare. So, if a vulnerability is discovered, basically Cloudflare can write a patch and deploy that across our global network within minutes or a couple of hours. Like we work very closely with the internet security community. So often they will tell us in advance of announcing a security vulnerability publicly. They will tell us, and we can write a patch and deploy it across our network and protect all 6 million Cloudflare customers very, very quickly. Whereas if you maybe have an on-premise firewall, the vulnerability might be discovered. You might have to rely on an announcement, and then the vendor who provided your on-premise firewall, you might have to rely on them distributing a patch, and that could take weeks or even months. So that is the wonderful thing about Cloudflare. We're able to really act quickly if we become aware of any major security threats. And we patch for all kinds of popular software platforms, including Oracle Commerce. So the next thing I'm going to talk about is performance. So, as Russell has mentioned, the performance of your website is super important for conversions, for getting your sales through. And here are just some statistics that help back up this claim. So, Walmart found that speeding up its web page load time by a second improved the conversions by 2%. So significant impact. Some data released by Amazon suggests that they found that 100 milliseconds slowdown resulted in a 1% loss in sales. And the Obama campaign, who was super cutting edge in their digital marketing, they found that for every 3-second improvement in page load time, they got an extra 40% more donations to the Obama campaign. So, these speed improvements can have significant improvement on the website conversion rate. So will really help sales. And there are all kinds of other things that Cloudflare does to improve performance. The CDN, which I mentioned earlier, Cloudflare will serve static content from those data center locations we have around the world, those 115 data centers around the world, and we have loads in the United States as well. So we are able to serve content closer to the users, so it gets to their browser much quicker. We also fully support modern SSL technologies. SSL is not just about security and encryption. SSL is also able to provide speed improvements and performance improvements for the website by using the latest SSL technologies. Cloudflare, I mentioned it a little earlier, Cloudflare DNS. We're one of the fastest managed DNS providers in the world. And by using Cloudflare DNS, which is optional, by the way, you can use your existing DNS provider if you wish, but we generally recommend you use Cloudflare DNS. Cloudflare DNS is widely considered one of the fastest in the world. And by shaving off hundreds of milliseconds from the DNS lookup time, that can again help speed up the performance of the website. We also have a recently launched service called Argo, which uses intelligent routing to speed up connections from Cloudflare to your web server. So essentially, the connection from the user to Cloudflare and then from Cloudflare to your web server is sped up. Basically, Cloudflare is using our own network to send packets of data across the internet via the most optimal route, rather than relying on the open internet, which can suffer from reliability issues such as packet loss or network congestion. So Cloudflare will intelligently send traffic the best way possible, and that can significantly speed up the website by, again, hundreds of milliseconds. We've seen some customers have half a second page load improvement thanks to using Argo. And lastly, we have load balancing. So I kind of mentioned this a little earlier. If you have multiple data center locations, load balancing will allow you to ensure maximum uptime and reliability for your site. Again, downtime costs money. So if you have two data centers, Cloudflare can send traffic to both of those, monitor the health of the servers in each data center, and if one of the data centers has problems, then we'll send traffic only to the working data center, for example. And we can also do geo-steering. So again, if you have customers in all over the United States, you have a data center on the, say, US East Coast and the US West Coast, Cloudflare can ensure that the traffic goes to the nearest data center. So again, that helps speed up the website for the user, and it will contribute to a fantastic user experience for the shopper on the site. So just a quick explanation of how Cloudflare works and is implemented in the context of a dynamic, or in the context of a Oracle Commerce site. We have, imagine this box is the Cloudflare service. Cloudflare will take all the web requests to the website from your visitors. Dynamic requests, which you can see here, signified by the top arrow. Dynamic requests will hit Cloudflare, will pass through Cloudflare's security layer, and then we will pass the request onto the origin web server, wherever you're hosting the website. However, for static requests, for example, say images or other static content like CSS, JavaScript, you can actually see the arrow here. It goes through the Cloudflare security layer. Every single request goes through the security layer. Then it hits the Cloudflare caching layer, signified here in green. So you can see that the static requests will go to the caching layer. Cloudflare will look if that asset, like image.jpg, is in the cache. If it is, then it gets served from the Cloudflare cache. If the image is not in the cache, then Cloudflare will fetch that from the origin web server for wherever you're hosting the website. And then Cloudflare will store that image in the cache. And then that image can get served from the Cloudflare cache going forwards. So essentially, this means that you can benefit from that global network that we have of 115 data centers to ensure that cache content gets served really, really close to the users, to the visitors accessing your website. So that was a very quick, high-level overview of how Cloudflare works. And I think now we're going to I'll hand back to Megan, and we can open up for questions.
Great. Thank you to Nick and Russell for presenting some great content for us. We now have time for a Q&A session with Nick and Russell, so feel free to submit any questions you might have in the questions tab of the console. I've had a couple come in, so I'll just start running through these and have Nick and Russell jump in. So our first one is how can edge side be used with Oracle Commerce to speed up and cache the dynamic content? So probably for either of you.
So I can talk a little bit about it, but edge side includes they're a little bit older technology, and they weren't really widely adopted because you had to do markup in your HTML to instruct the edge servers what to do. Cloudflare in particular has kind of taken a next generation approach in this, and they have a feature called Railgun. What Railgun does is you run an agent next to or on your web server, and you set up Cloudflare to speak to Railgun. The request goes back from the edge server back to the Railgun agent, which then calls the normal HTTP call. But if there's a cached version up at the edge of that page, then the Railgun agent will do a diff and send a binary diff back, as opposed to sending the whole HTML document back. This basically makes automatic edge side includes. I don't know, Nick, if you can correct me if I'm wrong in translation, or maybe go into more detail.
Yeah, absolutely. So, as we touched on earlier, static content can be served from Cloudflare's edge nodes across the world, but dynamic content can still be accelerated thanks to this Railgun technology that Cloudflare has, which is, I guess, as Russell said, the next generation of edge side includes. It basically, as Russell said, uses delta compression, so it's only sending the sections of the page that have changed across from your web server to Cloudflare. So if you imagine I had a shopping cart page. Now the shopping cart page, 90% of the content on that page is exactly the same for user A and user B. However, obviously just the shopping cart contents is different for user A and user B. So Railgun actually does special compression and only sends the shopping cart contents of the page across the internet, because those are different for, those elements of the page are different for user A and user B. And then the rest of the page doesn't have to get retransmitted across the internet because Railgun, intelligently just sends the changes, and then that can help, reduce the amount of traffic coming from your web server to Cloudflare, and again, that can help speed things up.
Perfect. Thanks, guys, for answering that. We have a couple more here. This next one probably for you, Nick. And it's, how does Cloudflare know what to cache and what not to cache?
Sure. Okay. So there are a few sort of settings for defining what Cloudflare caches and doesn't cache. So out of the box, by default, Cloudflare will only cache what we define as static content based on the file extension. So Cloudflare out of the box will only cache things like images, JavaScript, CSS, that kind of content, which is going to be the same for every single user. So that's what happens by default. You can then add more caching. So you can start saying to Cloudflare, actually, this HTML page, that's a good candidate for serving from the cache. And the way you do that, you can either send a header from your origin web server to Cloudflare. So as Cloudflare pulls the content from your web server, we will see that header, and then we will respect the caching instructions we get from your web server. So Cloudflare will actually just respect the industry standard cache control headers that are used for managing caching. Or the other way you can do it is using Cloudflare page rules. So page rules are just settings in Cloudflare which allow you to sort of modify and control the behavior of Cloudflare. And you can say in page rules, for example, anything with a .html extension, you should cache this. Or anything in this directory, you should cache this. And then Cloudflare will start caching more things. So it's very easy to set up. And generally speaking, customers will work closely with SparkRed and Cloudflare to ensure that the caching is set up optimally and everything that can be cached is cached.
Perfect. Thank you, Nick. We have one more in here asking, how easy is it to enable HTTP2 via CDN, and are there any downsides of enabling it, or things that need to be in place for it to work properly? Probably for you, Russell, to start, and then Nick, if you have anything else to chime in.
Sure. It's actually just a single setting inside of the Cloudflare console. It takes care of it on the front end automatically. Now, there are some things that you have to think about. Like I mentioned earlier, you do want your site to be SSL. HTTP2 only works with SSL. So ideally, you make your entire site, homepage and everything SSL. What you have to look for is, a lot of times marketing will sneak in web bugs or something, or there'll be direct references to HTTP calls from the pages, and you'll get that mixed pop-up, mixed content pop-up that you don't want users to ever see. So before you make your site all SSL, you'll want to scrub your JSP pages and reference stuff for non-SSL calls as well. That's really the only kind of gotcha that I can think of. We haven't had to change any settings at the web server level or anything like that.
Yeah, just to add to what Russell said, so the great thing about Cloudflare is that you can leave your web server with sort of legacy technologies. Your web server can just use plain old HTTP, and then you can enable HTTP2 on the Cloudflare side of things, and then HTTP2 will be used between Cloudflare and the user's web browsers. So basically, Cloudflare allows you to implement fantastic new technologies like HTTP2 easily between Cloudflare and the web browsers without having to mess around with configuration on your web server or your web infrastructure. Cloudflare will just handle it because Cloudflare is that reverse proxy sitting in the middle of the connection. So it's very easy to enable these kind of features.
Great, thanks guys. We had one more come in here. So regarding server push, how should you determine the limit of the number of assets to push?
So let me explain to give everyone context. Like server push allows you to populate the Cloudflare cache with assets, without actually the end users having to request those assets. So say you had a bunch of images or JavaScript or CSS, you could put that into the Cloudflare cache in advance of anyone actually requesting those assets, so that they will be there and ready to be served to the users very quickly when they request them. And to be honest, I don't think there should be a limit. Like generally, the Cloudflare cache will keep things in the cache unless they're not used significantly. So if an asset isn't getting used, then it might get purged out of the cache. But generally, if you are expecting traffic for particular pages or assets, then if they're in the cache, then that's great.
Basically, that you're just reusing that TCP connection for multiple assets that would need to go back anyways. So there really is no reason to limit the number of assets that go back, as far as I know. It reduces the number of redundant GET requests after that, right? So if you can push back all the assets that the server knows about, that's ideal.
Perfect. Thanks, guys. Okay, well, I don't see any more questions that have come in here, so thank you, everyone, so much for joining us today. We will be sending a follow-up email with a recording of the presentation as well as presentation slides, so feel free to review them afterwards or share them with colleagues who might find this information useful. So again, thank you so much for joining us, and I hope you have a great rest of your day.
Thanks, everybody.
Yeah, thank you.